Welcome back everyone to this channel. In this video, we're going to talk about linear first order differential equation. I'll show you how to solve a linear differential equation. Now, an equation of this form, dy dx plus p of x times y equal to q of x is called a linear differential equation. Okay, so let me show you the procedures for solving a linear differential equation. The first thing to do is to rearrange the given equation into the form that we have here, dy dx plus p of x times y equal to q of x. The second thing to do, the second step, is to determine the integrating factor. Alright, determine the integrating factor. That is IF. And integrating factor is e to the power of the integral of p of x dx. This is the integrating factor. Step 3 says substitute the integrating factor into the equation below, or the formula. This is the equation. Let me write it here. Y times integrating factor is equal to the integral of the integrating factor times q of x, that's this, dx. This is the formula. So after determining the integrating factor, we'll plug it into this equation. Step 4, integrate the right hand side of this equation, okay, to obtain the general solution of the differential equation. Okay, we can add step 5 to it. That is when there is an initial condition. Okay, if the differential equation is an initial value problem that has initial condition. So after determining the general solution, we can now apply the initial conditions. That is when the differential equation is an initial value problem. Okay, so let us go ahead now to solve some linear differential equations. If this is your first time of joining us, you can consider subscribing. And if this is not your first time, but you've not subscribed, you can do that now. Okay, so let's take two problems. Now this is the first question. We have to solve the differential equation 5 dy dx plus 17y equal to e to the power of 5x. Let us solve this differential equation. Now, by the procedures, the first thing to do is to rearrange this differential equation into that form that we had, that says dy dx plus p of x times y equal to q of x. Okay, so let's write this into this form, and to do that we have to divide both sides by 5 so that this 5 can be eliminated from this dy dx. So we have this dy dx plus 17 upon 5y equal to e to the power of 5x all over what? 5. So having done this, the second step is to determine the integrating factor. So the integrating factor is e to the power of what? The integral of p of x dx. Let's identify p. P here, compare, p of x is 17 over 5. Q of x is e to the power of 5x over 5. So this is the e to the power of the integral of p of x, which is 17 over 5 dx. Integrate 17 over 5 with respect to x. We obtain 17x all over 5. That is the integrating factor. This is it. So step 3 says we should substitute this integrating factor into that equation. The equation is this: y times integrating factor is equal to the integral of the integrating factor times q of x dx. So the integrating factor is this now, e to the power of 17x over 5, which is equal to the integral of the integrating factor, e to the power of 17x upon 5 times q of x. Q of x is what? E to the power of 5x over 5. So e to the power of 5x all over 5, then dx. So let's go ahead now. We have y e to the power of 17x over 5, which is equal to, this 1 over 5 can come out. 1 over 5 times the integral of e to the power of 17x over 5. By the law of indices, we are going to add their powers since their bases are the same, plus 5x dx. So what is 17x over 5 plus 5x? That will actually be 17x over 5 plus 5x. 5 times 5 is 25. So that will be 17x plus 25x all over 5. 17x plus 25x is 42x. Divided by 5, that is 42x over 5. So this will now be y e to the power of 17x over 5 is equal to 1 over 5 times the integral of e to the power of 42x over 5 dx. Step 4 says we should integrate the right hand side. Let's integrate this right hand side now with respect to x. Y e to the power of 17x over 5 is equal to 1 over 5 times, how do we integrate e to the power of 4x over 5 dx? The standard integral says that the integral of e to the power of kx dx is equal to e to the power of kx over k plus c. K here is 42 over 5. So going by this standard integral, this is equal to e to the power of 42x over 5, all divided by what? K, which is 42 over 5, plus c. So if I manipulate and simplify this algebra, I'll have y e to the power of 17x over 5 equal to 1 over 5 times, the 5 will actually go up, the 42 will remain at the bottom, then e to the power of 42x upon 5 plus c. 5 will take away 5. So we have y e to the power of 17x over 5 equal to 1 times this, that's e to the power of 42x over 5. Okay, let me write it again. E to the power of 42x over 5. This is over 42, so I can bring it out. Plus c. So, just one more step, let us divide through by this, so that y will be standing alone at the left hand side. So y is now equal to 1 upon 42 times e to the power of 42x over 5. Okay, if I'm dividing this by this, since they are the same, they have the same base, I'll just apply the law of indices. I'll subtract 17x over 5, subtract it from this. You get the point? They are the same base. So divide this by this, take the base, then subtract their powers. Then this is plus c all over, I'm dividing c by this as well. e to the power of 17x over 5. All right, y is equal to 1 over 42 times e to the power of. If we simplify this, their denominators are the same. So it is this. 42x minus 17x is 25x. 25x divided by 5 is 5x. So we have e to the power of 5x here. Plus c. I want to write this as c times e to the power of minus 17x all over 5. Okay, so this is actually the general solution of this differential equation. Okay, so let's solve one more problem. This one is an initial value problem. Okay, still on linear differential equation of the first order. Still on linear differential equation. But this one is actually an initial value problem. Solve x dy dx, x dy dx minus 2y equal to minus x squared. Y of 1 equal to 1. So this is an initial value problem. Let's solve it. It's a linear differential equation, but let's arrange this to the general form of a linear differential equation. We have to divide both sides by x. So this is it. Dividing both sides by x, dy dx minus 2 over x, hello, times y equal to minus x squared all over x. Dy dx minus 2 upon x times y equal to what? This is minus x squared divided by x. So by the law of indices, they have the same base. I can say 2 minus 1. And 2 minus 1 is 1, so we're having minus x. Okay, so it is now in the general form. All right. Let's identify P and Q. P of x here is minus 2 over x, and Q of x is what? Minus x, this. So the next step is to determine the integrating factor. And the integrating factor is e to the power of integral of p of x dx. And that's e to the power of the integral. P is minus 2 over x minus 2 all over x dx. Let us integrate minus 2 over x dx. The integral of minus 2 over x dx is minus 2 times the integral of 1 over x dx. Yeah, that's true. Minus 2 is a constant, so it can come out. The integral of 1 over x dx is ln x. Okay? Because the derivative of the denominator is the numerator. So the integral of the function is ln x. That is minus 2 ln x plus the arbitrary constant c. Okay, but take note, we are not going to add arbitrary constants to our integrating factor. Okay? Yeah, we are not adding it. This is just the integral of this function, generally. But we are not adding the c to it. So let's simplify minus 2 ln x. By the law of logarithm, this minus 2 can stand as the power of x. That's ln x raised to the power minus 2. So this integrating factor will now be e to the power of, everything here now is ln x raised to the power minus 2. Ln x raised to the power minus 2. Also, remember that ln, let's say ln x is the same thing as saying log x to base e. So the law of logarithm says that if we have e to the power of log b to base a, the a will take away the log and the base a, leaving us with just b. Okay, so in this case now we are having e raised to the power ln x. So the e will take away the log and the base e, leaving us with just what? X. So in this case now we are having x raised to the power minus 2. This will cancel, we have x raised to the power minus 2. So this is the integrating factor. The next step is to substitute that integrating factor into the equation that I've written before, and I'm going to write it again. Y times integrating factor is equal to the integral of the integrating factor times q of x dx. Okay, so y times the integrating factor is this, x raised to the power minus 2, x raised to the power minus 2, which is equal to what? The integral of this, which is still x to the power of minus 2, times q of x is minus x dx. Take note, we are determining the general solution first of this differential equation, and after that we'll now apply these initial conditions. Y into x to the power of minus 2 is this. Multiply these two together, they have the same base, so it will be the powers now. This is to the power of 1. We have x raised to the power minus 2 plus 1. Minus 2 plus 1 is minus 1. So this is now the integral of, the minus can come out, x to the power of minus 1 dx. So minus x to the power minus 1 dx is actually 1 all over x. Okay, so we have y x to the power of minus 2 equal to the integral of 1 over x dx is ln x. We did that before. So we have minus ln x plus c. Dividing both sides by x to the power of minus 2. This will cancel this. Y is now equal to, this x raised to the power minus 2 here is negative. If it goes up, it becomes positive. That will be minus x to the power of 2 ln x plus the same thing here. If I invert it, I'll see x to the power of 2. This is the general solution. So it is time to apply the initial condition now. The initial condition is this: y of 1 is equal to 1. So when x is equal to 1, y is equal to 1. This 1 here is for the x, and this 1 is for the y. Okay, so in place of x here we can put 1, and in place of y we'll put 1, and we'll solve for c, the constant. So 1 is equal to minus 1 squared, x is 1, ln 1 plus c times 1, which is c. 1 squared is 1. So let's solve. This is 1 equal to minus ln 1 plus c. What is ln 1? Ln 1 is actually 0. Okay? Generally, log 1 to any base is 0. Yes. So this is 1 equal to 0 plus c. C is actually equal to 1. So why this is the general solution? Given this initial condition, the particular solution is this: y is equal to minus x squared ln x plus, what is c? C is equal to 1. So we have 1 times x squared, which is x squared. This is the particular solution, and this is the what? General solution. I hope you enjoyed the video. Keep supporting by subscribing to this channel, like the video, and share it to your friends. I'll see you in the next video.